Up to this point, we've been discussing individual charges in specific locations. The charges had different varying sizes or magnitudes. But let's look at another situation where we have a charge distribution across a certain path. I'm going to expand this out a little bit. So this path has an infinite number of charges. There's no space between them. Imagine that these plus signs are all over the place here along this line. And now the question becomes, what is the electric field at some point away from this charge distribution? Well, what we have to do is look at what we call a differential charge. If I have some little charge here, we'll call it dq, this little charge is going to have an effect on this point, some differential electric field. So our electric field equation for differential becomes differential electric field is equal to 1 over 4 pi epsilon naught dq over, and we're going to, this is probably not the most logical way to put this, but I'm going to put it this way just so that you know that the distance is related to the charge location squared. So this is your distance r. Now, if I want to find the total electric field at that point, then it's going to be the integral of my differential electric field. So now we need to understand how to solve these problems. Well, the first part is draw the diagram. Very important. If you don't understand the orientations and the directions, you'll have a hard time understanding how to solve the problem. The second part is apply Coulomb's law in differential form. Third part, and this kind of takes multiple possibilities here. First part is look for symmetry. To simplify. If that doesn't work, then you need to identify the vector formulas, component formulas, I should say. And integrate separately. Now you're going to find that we're going to be able to use part A for most of our examples. We'll be able to simplify these problems in such a way that we won't have to do this vector part. Very rarely would it ever get to this point because symmetry is usually the easiest ones to look at. If you have non-symmetric problems, then you're probably going to do the final would be a computer simulation. And we don't have the ability to do a computer simulation. But we'll be able to do some kind of simplification that will get us from having to do the more difficult types of problems. So let's take a look at some different ways we can calculate the electric field at specific points based on an electric field differential or distribution. So we'll be doing those in the next few videos.